Well, she said do it today, so when we come in, do it that day, so that we can, when we come into today's class, we can only talk here, we have to talk about it.
And then, no, and surprisingly, I actually wanted to do it, but I told that to go back to sleep, but now I
We're
got
all
sleep.
like,
And that is why.
Okay, your exam 4, have you all taken it yet?
Yes.
Awesome. Okay, I was gonna say, I have it due on
I got the review.
Saturday.
I wasn't stressed
I
about it
was
until
looking
last
at it
night.
then last night.
Yeah. I
Okay,
wasn't
so
stressed about
it
the
is due
final.
Saturday at 11. If you have not taken it yet, I'm just trying to encourage you to get it out of the way so that you can work on this final exam review. Okay, so your final will be Tuesday and Thursday. Tuesday I wrote down that I'll come from 9 to 12. Does that still work, or does someone want me to come at 8?
I think I don't even remember what time my thing is, 9 something. Yeah. How long do we have to do
My
it?
world has it till 9.
2 hours once you start. Okay. So still come in at 9?
I think 9's fine.
Okay, and then Thursday we'll do 8 to 10 if needed, okay? So Tuesday I'll be here from 9 to 12, Thursday from 8 to 10. Your test has 25 questions. So that's just 5 more questions than normal and then 30 more minutes than normal, okay? So 2 hours to take that. Now, when you come in to take your test, we'll just see one person at each table. You can use anything you want to on paper. You just can, online, you can only be on your test. So I'll be sitting in the back of the room to proctor that. You can't use your phone, okay? And some of them yesterday were asking me about like what your grade has to be on the final. Okay, we just say that your grade, you have to pass the final in order to pass the class because this is the only test you're taking in person. Does that make sense? So it's not, so somebody got that they had to make a 70 on it, but that's not, you just have to pass the final regardless of what your grade is. So that's why we have 2 opportunities to take it. So if you are not happy with your grade on Tuesday, you're welcome to come back on Thursday to take it again. And there will be a personalized review like
So
usual.
what's considered passing?
Do what?
What's considered passing?
60. Okay. Joe, it's not gonna be a problem. Okay. I know, when my son took college algebra in high school, like he did a lot of dual credit, but they were all either in person at the high school dual credit, or he did a few classes online through Western and OCTC, but none in person. And when he did college algebra, it was that same rule. You took all your tests at home, but then he had to go in person to take the final. And of course, he'd never really been on campus and been in a class or anything, so he was like petrified to like walk in there and take it. And he had an A going in, and he made like a 72 or something. He had to make a 70 to pass, and he made like a 72, and it brought him down to a B, and he refused to go back and take it. He was just so intimidated by being in there, and there was somebody he didn't know sitting beside him. He thought they were looking off his paper, and he was afraid he was going to get in trouble. And he's like, "No, I'm good. I'll take my B. I don't care. I don't want to go back in there." But hopefully, y'all been around. You're not going to be. You can still come in and same room you're used to being in, and all that good stuff.
And where will that be at? And what day did you
Here.
guys say that?
Tuesday from 9 to 12 and Thursday from 8 to 10. Okay. Just come in whenever, and you have 2 hours once it starts. So you want to get in here, by 10-ish on Tuesday to be able to make sure you finish. Okay. Is that working?
Yep.
Okay. All right, let me know if you have any conflicts or anything like that, and bring your laptop. Okay. Which I think we talked about that. I'll have mine with me, so if there's, some kind of issue and you're just cooperating, don't panic. You can use mine, and we even have this desktop if somebody needs to use it.
And you said we can bring like our review.
Yes, you can use anything you want on paper, you just can't be on anything else on your computer.
So we can bring we've all.
So you can write anything down and use anything on paper, okay?
Basically, you can't use Jagger Quizlet.
Yep.
End of the day.
So, I haven't done all of these review yet, but I do remember there were some parts of
tests that we had to do in the past. I think it was unit 3, where it would ask you for like what the Z-score was for a certain number, but that wasn't one that's in the table, and we did have to go out and look that up.
I didn't notice anything off here. So if you're in the middle of taking a test and it's not on the table,
Okay.
you know, you're with me. So let me know and but I didn't notice anything when I went through it. And the only thing I noticed yesterday as we were finishing, there was a problem or two where it didn't have the T chart on here. Like most of them do, but then there was one that did not. So if I can't figure out how to get it on the test, then I'll make sure I bring you paper copies just to be like for the T distribution chart or the.
Was there another question that had it on there?
Yes,
Okay.
there was another one that had it on there, but I just don't want you to freak out there with the timer, you know, and be like, oh, where is it? And have to waste 5 minutes looking for it. So I'll double check, and if I can't get it embedded on that question, then I'll bring you a paper copy in case you need it. Okay. All right, so starting with the review on this first question, we're going all the way back to probably the first day of stats. We want to determine whether the statement is true or false, and if it's false, rewrite it as a true statement. And my statement is the population is the collection of some outcomes, responses, measurements, or counts that are of interest. That was actually false because the population is the collection of all of those things. So it should be B. To include that it's the collection of all outcomes. Okay, then number 2, same idea. My statement this time is data at the ordinal level are quantitative only. And that is also false because at the ordinal level, it could be qualitative or quantitative. And then number 3, the variable is a favorite musical band, and so we need to determine if it's qualitative or quantitative. And this one should be D. The variable is qualitative because a favorite music band describes an attribute or characteristic. Okay. Quantitative usually means more like you're counting how many.
In this case, it's a sport, so it doesn't matter either way, right?
So it should be the favorite sport. Yeah, it should be the same then. Qualitative because it's describing an attribute or characteristic. Okay, if it's quantitative, it's going to be something about counting. Okay, well, if you're naming your favorite musical band, you're not counting. If it asks you how many favorites you have, then you would be counting, but just naming it, it's because of a specific attribute or characteristic. Okay. All right, next problem. Okay, a pharmaceutical company wants to test the effectiveness of a new allergy drug. The company identifies 250 females 30 to 35 years old who suffer from severe allergies. The subjects are randomly assigned into 2 groups. One group is given the new allergy drug and the other is given a placebo that looks exactly like the new allergy drug. After 6 months, the subject's symptoms are studied and compared. Okay, and then our first question is to identify the experimental units and treatments used in the experiment. Okay, and so the first one should be B. The experimental units are the 30 to 35-year-old females being given the treatment, and the treatment is the new allergy drug. And then identify a potential problem with the experiment design being used and suggest a way to improve it. So a problem would be that there could be bias on the part of the researcher if the researcher knows which patients are given the real drug. And then C, how could this experiment be designed to be a double blind? Okay, well, if it's a double blind, then that means the researcher nor the patient know who receives the real drug and who receives the placebo. So that should be D. The study would be a double-blind study if both the researcher and patient did not know which patient received the real drug or the placebo. Okay, then on number 5, use the data set listed in technology to create frequency histograms with 5, 10, and 20 classes. Okay, so the classes were when we took the data and we separated it into like groups, and then you would go through and look at the numbers and count how many are in each group. So when it has 5 classes, that means it's going to have 5 groups that you're separating it in. 10 classes would be 10 groups that you're separating it into. 20 classes would be 20 groups, and so on. Okay. So what you have to do to figure out your groups is look at your range of numbers. So my smallest number is 1 and my largest number is 15. So that's going to make my range 15 minus 1. So my range is going to be 14. Okay. So then you take this number and divide it by how many classes you want. And then you're always going to round up. So on A, we want 5 classes. So I do 14 divided by 5. And 14 divided by 5 is 2.8. So that means that my groups are going to be have a width of 3. So if I make my first group 1 to 3. Okay. Okay, and you all remember I have this recorded too, so you can always go back and pick up on a few of the details. Okay, so do you see where I got the range?
You just subtracted the high.
I look at the highest and lowest number, so that gives me a range of 14. This one, first question wants 5 classes, so I divide by 5 to see what my groups need to be. And it tells me my width of each class needs to be 3 because you always round up. So this one was 2.8, so you would make it 3 regardless. But that means, if you'll remember from the classes, when you separate them, my first group is going to be 1 to 3. My second group would be 4 to 6 because this width is 3. And same over here, that's 3. My next would be 7 to 9. Because once again, 4 to 7 is 3, 6 to 9 is 3. What would my next group be?
10 to 12.
10 to 12, and you would just keep going like that. Now, there's no reason, since this is multiple choice, there's no reason to actually go through and name each class and go through and count and do like a frequency distribution for each class. Because look at the bars. For the most part, yeah, you can just really look at the first class and see how tall the histogram bar is. Okay, so once you figure out what a few of your groups should be, just stop, okay, to save some time. And then you want to go back and say, okay, the 1 to 3 group, how many numbers fall in the 1 to 3 group? Okay, well, here's 1, here's 2, 3, 4, 5, 6, 7. Okay, so my 1 to 3 group is 7. So more than likely I can even stop there and I don't have to count how many I have in 4 to 6 or any of the other classes. Let's make sure we only have one choice where the first histogram bar goes up to 7. And it looks like that is the case. This one's at 7, that one's at like 3, 3, 8. So yeah, it's just gonna be A and I can stop. So save yourself some time. Sometimes you may not have to work out the entire
I
problem.
don't have one. Well, mine's just
Yeah,
Okay.
never mind.
mine cuts off. Like when
Yeah, and you all probably have different numbers than I do. So, just kind of pay attention to make sure you know what it's doing and make yourself some notes. And then you can go back and look at yours with your numbers later if you need to.
So you divided 14 by 5, so would you divide 14 by 10 and 14 by 20?
Yep. So next I'm going to take 14 divided by 10. That's going to be 1.4, but I'm going to round all up always. So this one, my width is going to be 2. Okay. So that means my first class would be 1 to 2. My second class would be 3 to 4, then 5 to 6, and so on. Okay.
I don't
Because this width is 2, from 1 to 3 is 2. And then over here from 2 to 4 is 2. So the lower limits and the upper bound are 2. Okay.
And that right there is how,
Like how many?
How hard the bars are.
Mm-hmm. Okay. So now I'm going to say, okay, my first bar is measuring how many 1 to 2s I have. So then I go back to my data again, and I count how many 1s and 2s do I have. So I have 1, 2, 3, 4, 5, 6. So I have 6.
What are you getting whenever you're dividing the range out of class? What is
I'm
it?
getting my class width, so
Okay.
like this was 2. Okay, so now I need to look for which histogram the first bar goes up to 6, and I only have one option. So that's going to be B, and I don't have to count anymore. Now, if you end up with 2 different histograms that go to 6, then just kind of look through and see, okay, where do the bars vary, and then count that class, okay, to save yourself some time. Okay, the last class, we have 20 classes for this last histogram, so I take 14 and divide by 20. That's going to round up to 1. And so that means I'm just going to do 1, 2, 3, 4, so on. Okay. So I'm going to count my 1s. Now this time when I count my 1s, I may have a conflict, but we'll look and see how it goes. When I count my 1s, I have 1, 2, just 2. Okay. Well, if I look both B and D, the first one goes up to 2. So I don't know which is which, but I'm noticing my second bar is very different. The D is very low and the B is really high. So I should be able to get it settled by counting the 2s now. So when I count my 2s, I have 1, 2, 3, 4, just 4 2s. Okay. And B is the one where my second bar goes up to 2. On D, it only goes to like 1. So I can stop there. Okay, then number 6 is comparing a stem and leaf plot to a histogram. What are the advantages and disadvantages there? And then the next problem will actually make a stem and leaf plot. So the advantage of a stem and leaf plot instead of a histogram is that the stem and leaf plot contains original data values where the histograms do not. Okay, especially like that first one that I just made. Here, I had a class from 1 to 3. So when I look at my answer, I know there's 7 numbers from 1 to 3, but are they all 3s? Are they all 1s? Are they all 2s? I don't know. Okay, so that's what that's referring to. Okay. So your stem and leaf plot that you'll see here in just a second, if you've forgotten what that looks like, it actually has the original numbers. So you would know how many 1s, how many 2s, how many 3s. Where the histogram, you just have the bar for the class. Okay. Now, a disadvantage of the stem and leaf plot instead of the histogram is going to be the histograms easily organize data of all sizes, where the stem and leaf plots do not. Okay, everybody good so far?
Yeah.
Okay, so here's our stem and leaf plot. Okay, this wants us to make a back-to-back stem and leaf plot, and so we have 2 sets of data, the 3 p.m. class and the 8 p.m. class for this yoga class. You're going to put the data for your 3 p.m. class on the left, and then for the 8 p.m. class on the right. Okay, it's showing you at the bottom that if you put in the 1 row, if you put a 0, then that means you have the number 10. Okay. It also says to write things in ascending order. I had a hard time with that on the 3 p.m. class because it's like I want to put the numbers this way, okay, but it wants it in ascending order. So just kind of watch for that. You don't want to miss it because you put them in the wrong order. So starting with the 3 p.m. class, the first number I have is 46. So I go to my 4 and I'm going to put a 6 there. Okay. Then I have a 68. So I'm gonna go to my 6 and put an 8. 59. Okay, and notice this is what I'm talking about. I put the 9 all the way to the end because when I have another 50 something, my numbers here are going to need to be in ascending order. Okay, so 9 would be your last number, so that's why I put it at the end. I left room for my 6 and 8 to put numbers before and after that. Okay, 74, 60, and you're just going to go through and put your numbers in. Now, to me, this is a little bit tougher on when you're doing the problem on the computer because you can't mark the numbers off as you write them down. So I would do a quick check and count how many numbers were in your table and then how many you have on your stem and leaf so you can make sure you didn't forget one. Okay, then you'll do the same thing for the 8 p.m. class. Okay. And those were a little easier to write in ascending order. Do you see what I'm saying? Writing them backwards. Like
Yes,
I
I
didn't
can
want
tell
to,
by
like
that.
I wanted to go that way instead of forward.
What does the key mean again?
So, like, for example, here, this means 38.
Oh, I don't know.
Okay, so if I put a 0 here, then that means I had the number 10 in my chart. Okay, so my first number is 19, so I'm going to put a 9 there. That means 19. Okay.
Oh, I see it.
You see what I'm
Yes,
saying
I
now?
saw that.
Okay.
Yes, that first part is hard. I have to really like think about.
Yeah.
Doing it backwards.
And I almost think that that would be easier typing it than writing it because you can
Yes.
easily insert a number, whereas when you're writing it, you got to erase. But yeah. So do you see what we're talking about now with the stem and leaf plot? Like you can see the actual numbers were on the histogram. You just know how many are in each class. Okay, and then from here, you are going to just answer some questions. My first question is, what are the lowest and highest ages of each participant? Okay, well, you can see that easily because when you're looking at the stem and leaf plot on the left, the first number, 35, is going to be your lowest age group. And then the oldest age for that would be your last number that you have there, 77. And then do the same thing on the other side. My first number is 18. And my last number is 71. So that would be the oldest.
Can we export these like we can on MATLAB when we're taking a test? Like, would it give you the option to export those numbers into an Excel, maybe?
I think it would. Does anybody have it pulled up? Like you might be able to see on the review if it'll allow you to do that.
Yeah, I think.
It doesn't say.
Yeah, it's open it, look at the hand review. You can click on the little icon and it says open.
Okay.
Okay, good.
And so, yeah, if you want to use Excel, you're.
It's ready, it's easier for me to read it that way.
Yes, for sure. Okay, and then how many participants are in each class, which like I said earlier, that's a good idea to check anyway, just to make sure you didn't accidentally forget a number. But 1, 2, 3 times 4 is 12, and this is 3 times 3, 12 and 9 give me 21 in the 3 o'clock class, and then 1, 2, 3, 4, 5, 6 times 4 is 24 in the other class. And then it's wanting you to compare the distribution in each class and what observations can you make. Okay, and I'm thinking it's this one, the average age of the 3 o'clock class participants are much older than the 8 o'clock class. The 8 o'clock class is very concentrated on participants 20 or younger because you have so many in those first two groups.
Is that the difference between your Thursday class and your Tuesday class?
Yeah. Okay, everybody good with that one? Okay, moving on to 8. When you're looking at that histogram, you're determining whether the shape shown is symmetric, uniform, skewed left or skewed right. And this one's actually skewed right, and the reason is because the tail is to the right. Okay, then on the next one, we have some data here that gives the ages and the heights of pitchers for a baseball team. It wants us to find the coefficient of variation. So my formula for the coefficient of variation is to take the standard deviation, divide it by the mean, and multiply by 100 to get the percent.
I guess I missed number 8.
We said it was skewed right because the tail is to the right. Okay, on number 9, in order to get our standard deviation and mean, we can do the one variable stats with our data down here. So what I'm going to do first is take this chart and enter my heights in L1 and my ages in L2. Oh man, I didn't move over like I thought I did. Crap. Okay, once I have my data typed in, I'm going to go to Stat and go to Calc. And number 1 is the one variable stat. So that's what we use anytime we want to define the standard deviation or mean. Okay, so I do my one variable stats, and I actually have 2 variables in there, but I'm going to do the one variable stats for each of those lists. Okay, I just went ahead and typed them in all together just to save me a little bit of time. So the first one asking me for the coefficient of variation for the heights. So I put my heights in L1. So my list needs to say L1, and then I don't worry about the frequency list. I go to calculate and enter, and there are my one variable stats. Okay, so to get my CV for the heights, I'm going to take my standard deviation over my mean. So my standard deviation is here. It is 2.896. And then I'm dividing by my mean. My mean is that first number, the X bar, 74, divided by 667. Okay, so once I've written those numbers down, X bar is the sample mean, where this is the population mean, but for what we have, either one's fine. Okay. So if I quit, then I'm going to take 2.896 and divide it by 74.667. I multiply that number by 100 because it wants a percent. And then it tells me to round to 1 decimal place. So that's going to be 3.9% for the heights.
X bar is the mean.
Mm-hmm. Okay, then I'm going to do the same thing for the ages. I typed my ages in L2. So that just means that next, when I go to do the one variable stats, I still go to stats and calc and one variable stats, but now I need to say define the one variable stats for my list 2. Now you can just type this in, do everything, and then go back and type the ages in L1 and override that. You know, type over this, that's fine. Okay, but you can also, if you type them in together, then all I have to do here is change that L1 to an L2. Now, do you see at the number 2, I have that little blue L2? Okay, that's what I need to use. So I hit the blue key and then number 2, and now it's L2. Now, if you type in, sometimes people want to type in, like use the alpha button and type in the letter L and the number 2, but it will make a big 2 beside it, and it won't look, it doesn't know you're going to that list, okay? So I did second 2. It's there in blue, so I hit the blue key.
Oh, then second 2, yep.
Okay. Okay, there's my numbers for that one. So now when I do the coefficient of variation for the ages, I'm going to take my standard deviation of 4.517 7 and divide it by my mean 28.0833. Okay. Multiply by 100 again to get the percent, and when you round this one, it's gonna be, mine's gonna be 16.1. Okay, so then when you compare the results, okay, the ages are more variable than the heights for my data because it has the higher percentage.
It's always
Can you wait just a minute?
standard deviation divided by the mean
Mhm.
times 100.
Mhm.
So I was rounding to one decimal place whenever I was.
Doing this part, I would try not to round the numbers you get off of your one variable stats. I mean, you have to round them somewhat, but I would go out 3-4 spaces. So on this one, I chose to go to 3 because after my 6 was like a 2 or a 3, it was a really small number. Where this one, I decided to go more because my next number was a larger number after the third one. Okay, so if you round to, just to the nearest tenth, then you might end up being off a little bit by the time you do this. So I'm not sure if how much variation will give you in your answer. So I would try to go out 3 or 4 places.
So on the ages, did you use the OX at the end, or did you use the S?
The OX. Okay. And then my bottom number was the X bar.
Okay, I thought it was wrong, but then on here it says it should be S over X bar times 100%.
Well, I think in math lab, a lot of times instead of using that circle with the squiggly thing on top, they use S.
They use S for standard deviation.
Because I was getting myself super confused during the standard deviation section.
Because
our
they
calculator
were,
says one thing, math lab says something, and then you wrote something else. And
Okay.
I was like, wait, that's why, I was like, if I have to hear standard deviation one more time, I'm going, like,
Yeah,
but that's why.
I have an S and a standard
Well, I mean,
deviation.
I used the O,
So what did you just use? the
I just
standard?
wrote down on this one, I wrote, OX is standard deviation.
Okay.
but that's what I used, and then
So
I divided it. from there.
you might double check your data then. You may have typed in a number wrong. That would cause you to get the wrong thing off of your chart.
Hello?
And we still use standard deviation divided by mean times 100
Uh-huh.
for L1 and L2.
Yes.
Okay.
Okay, next we're determining whether the statement is true or false. Okay, and then if it's false, rewrite it as a true statement. So it says it is impossible to have a z-score of 0. That is a false statement. Okay. When you have a z-score of 0, then that just means the standardized value is equal to the mean. Because remember that z-score, like when you're thinking about your graph, that was always our mean. So if your z-score is 0, then that just means your standardized value is equal to the mean. And then number 11, what's the difference between an outcome and an event? An outcome is the result of a single probability experiment, whereas an event is the set of one or more possible outcomes. Okay, then my next problem says identify the sample space of the probability experiment and determine the number of outcomes in the sample space. And my scenario says guessing the last digit in the price of a TV. Okay. So all the possibilities of the last digit in the price of a TV would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that gives me 10 possible outcomes in the sample space. Okay, next, we're going to classify the following statement as an example of classical probability, empirical probability, or a subjective probability. Okay. Now, classical meant that it was equally likely. So our example for classical is like rolling a dice. Okay, you're just as likely to roll a 2 as you would be to roll a 5. Okay, that's classical probability. Subjective is just like intuition or estimates. Okay, so based on, I feel like everybody will do well on the stats final. Okay, that is a subjective statement. Mm-hmm. And then empirical is going to be based on statistical data. So our scenario is, according to company records, the probability that a washing machine will need repairs during the 10-year period is 0.08. Okay. So that is going to be an example of empirical data, okay, because it's based on company records. And so for the second part of that question, you're going to look at the part that says it's based on company records right here. The stated probability is calculated based on observations from the company records. Okay, the table shows the number of male and female students in a particular country who received bachelor's degrees in business in a recent year. We need to complete the questions below. We want to find the probability that a randomly selected student is male, given that the student received a business degree. So when I'm looking at this problem, okay, the number of students that are male, right here, I have 189,107. And then given that the student received a business degree, well, the total number of students that received a business degree are 361,702. So when I type in that in my calculator, I need to round to 3 places.
Why those two numbers?
Because it says find the probability that the student is male, given that the student received a business degree. So males that received a business degree over the total number of students that received a business degree.
So like picking the males out of the group.
Mm-hmm. And the group is this big. Okay, on B, find the probability that a randomly selected student received a business degree, given that the student is female. Well, this time, the total number of females that received degrees are this number, so that's my denominator, that's the group I'm picking from. And then the number of females that received, out of that group that received the business degrees is 172,595. So that's my numerator. And I'm rounding that to 3 places. Okay, 15, you can put this in your calculator. Okay, there was a formula, but we did not deal with the formula. We just used the button on our calculator. So to get to combinations, we went to math and then over to prob for probability. Okay, and we used the NPR for permutations, we used the NCR for combinations, and then we used the factorial a little bit there on number 4. So those 3 functions are the 3 that we used in that feature. So it was math and then over to prob. Okay, so once I pick my combination button, then I just type in my numbers and that'll tell me my answer. So math prob for probability.
And then this one's a C, so we do the number 3.
Mm-hmm.
Okay.
Math, wrong.
I think you and I'll do that first number, and then we go, and have to put it in.
Yeah.
NCR.
Uh-huh.
I have to do that too, I agree.
Yeah, I did.
So,
It may not be updated, which we could do that, but not sure there's a point. Let's
So
see.
late now.
So math prob.
The number to the left first, and then do your math, prob, and
I don't
CR,
do
and
it.
then put the number to the right.
Yeah, if you do, get all those, always forget.
Oh, yeah.
Okay, then on 16, we have a probability distribution chart.
1 second.
Oh, girl, the problem I had before with the little chart, I had 666 and you just answered.
No,
666.
I'm like, I wrote that
I was
down
like,
and I
oh,
thought,
God, I don't wanna write this.
At what number? We don't need that choo-choo.
I'm not gonna say anything. I'll see if they do. My other class didn't notice what you all did.
I was
I'm
like, oh. Sorry, I was raised Catholic.
So, once you go to math, prob, and then you get the NCR.
You'll have to type in your number first. You have the other calculator, so clear that out. Type in what your number is. What's your first one?
A lot of ins and outs.
25 and then the NCR. Yeah. Make sure. Okay, so for my probability distribution chart, this is telling me the probability for having 0 TVs, 1 TV, 2 TVs, and 3 TVs per household. Okay. So on A, find the probability of randomly selecting a household that has 1 or 2 TVs. Okay, well, my 1 would be 0.11, and my 2 is 0.31, and so I add those together to get my answer. So if it's 1 or 2 TVs, I add my numbers in 1 and 2. My next one says 2 or more. So my 2 and my 3 is what I need to add together. Okay, next one says between 1 and 3 TVs. So you could do this one of 2 ways. Between 1 and 3, you could add the 1, 2, and 3. Or I'm noticing that I only have one number that is not in that group. Well, what do all of the probability distribution numbers have to add up to? 1. So it would probably be easier to just do 1 minus the 0.01. Okay, that should get you the same thing as adding those three. Okay, remember that was called complement? Okay. So if it doesn't have between 1 and 3 TVs, then it would have 0. So I just do 1 minus my 0. Okay, find the probability of selecting a household that has at most 2 televisions. Okay, so that's just going to be 1 minus 0.57. Okay, so if it has at most 2, that means it doesn't have 3. So I just subtracted my 3 from that to get 0.43. Okay, on my number 17, I have a graph, and it's asking me to determine whether the graph could represent a variable with a normal distribution. Okay, so does that look like a normal distribution?
No.
What's wrong with it?
It close, yeah.
It crosses the x-axis, so that's my answer on that. Okay, then on 18, this time we do have a normal distribution and we need to answer the questions. So first of all, it's saying what % of the scores are less than 19. Okay, this one gives us the standard normal distribution table, but we really didn't use that one. That table was a little bit more complicated to look up, and we just chose to use our calculator instead. So if I'm saying it's less than 19, well, here's 19, and so this is what that would look like, that part less than that, okay? So I'm going to do the normal CDF, okay? Now here's my trick as to how I know to do the normal CDF. Okay, well, it's given me the normal distribution table. It's talking about normal distribution, so that's why I'm using the normal function on my calculator. Okay, I do not, the first thing it asks you under normal CDF is the lower bound. Okay, well, it keeps going to the left. So that's the -1E99, or you can type in -10,000, but this is what your calculator defaults to. Then it asks you for the upper bound. Well, what is my upper bound? 19. And then this one has a mean of 21.4 and a standard deviation of 5.3. Okay. So I type that in. Okay, this is what it looks like. Okay. And then my answer, they're wanting it as a %. My answer gives me a decimal. When it says round to 2 places, I'm going to say 32.53.
Is it always the mean and standard deviation?
Mm-hmm. Okay. And if you, because we got to the point where we were doing a lot of these and we would just take the previous line and copy it and change the numbers. But when you're actually going to that function on your calculator, okay, it asks you for the mean and the standard deviation. So if you forget what number goes where, because sometimes I would accidentally mix those up. I noticed when I was doing that. Okay, you can always go back to the menu and see where to put things. Yours didn't tell you that part?
No.
I thought it did
I
that
put it
part.
all in.
Okay.
And I
Yeah,
did-
so make a
and
note that
I
this
did-
is mean, that's standard deviation, that's lower, and this is upper.
It's hard mode over here.
Lower, upper, mean, standard deviation. Okay, then my next question says, how many scores would be expected to be greater than 21? So that means here's my 21 line, and then it's going to be shaded this way. I don't know if y'all could tell that that's a different color pen, but how about I shade it like that? Okay. So now I'm looking at this part rather than this part. Okay. So when I type it in this time, my lower is the 21. My upper is the 10,000 or the 1E99. And then you can leave the 21.4 and the 5.3. So this one would be a good one to copy because your last two numbers are the same. And you know you can get that line to come up by hitting second enter. Okay. And then I'm just going to go over and make my first number instead of -1E99, it is 21. And then my second number, I can type in 10,000 instead of that. That works. And that gives me 53.0. Oh, no, wait a second. It does want a whole number. It says out of 1,500, how many would be greater than 21? So I take that number and I multiply it by 1,500. So I would know the actual number. So 795.
Oh, yeah, because mine was on 8, I get 23.253 instead of 32.
Okay, and that's just because it has that percent after it. So when you got that, then you're just going to move it over 2 places.
You said you just took that in times it by 1,500?
Mm-hmm. And that's because it says up here out of 1,500.
Hold on. Okay, because B, because it said out of.
Mhm. Yeah, and I didn't go back and read the question. I was reading the rest of this response, so I kind of forgot about that part. Okay, on 19.
One second.
Mhm.
Can you just take number 21 off? I just don't need it.
That wasn't bad.
I hate number
You
21.
hated that?
I cannot figure those out.
Oh, hey, no. I'm sorry, I get it wrong.
Wait,
It doesn't matter what you read it, I'll put it in there.
It'd be like small, big, big.
Even if it's
small,
right,
big.
it's never right.
Oh, where am I?
That's what I said.
He was looking ahead.
It's like there.
Oh, God. The boxes.
Now you know what we was talking about.
They're so funny.
Okay, on 19, this time it's giving you the area and you need to find the z-score. Okay, so we're going to be doing an inverse function this time, and we're still talking about the normal distribution, so it's going to be the inverse norm.
Next.
So inverse norm.
Second one.
Second bars, inverse norm. Okay, my area is 0.1251. Okay, and then the mean is 0, standard deviation is 1. Okay, and then it gives me this negative number. Now, can that be a negative number?
No, because it's a
Mhm.
right tilde.
So I'm going to write the positive. So what happened here was it was actually giving me the z-score for this, okay, because I put in the area, when you're finding the z-score, it's always the area to the left, and since my area was to the right, okay, I could have gotten the positive by taking 1 minus this number because the area under the curve is 1. So if I wanted to find the area of all of this, then it'd be 1 minus that, okay? But I think it's just as easy to just pay attention to your number and know if it makes sense, Okay. And so then that would be a positive 1 point. How far do we round? 2 places, 1.15.
So it's positive because it's to the right.
Because it's to the right.
To the right, to the right.
Okay, number 20, we're still looking at the normal curves. It's still giving us the standard normal table. Okay, but this time we've got a scenario to look at. So the height of the women is normally distributed with a mean of 64.6. So this is my mean. My standard deviation is 2.8. Okay, are you more likely to select one woman with a height less than 65.6 inches, or are you more likely to select a sample of 18 women with a mean height less than 65.6 inches? So on this first one, what is the probability of randomly selecting one woman with a height less than 65.6 inches? We're going to be doing the normal CDF again. Okay, because you remember your probability is the same thing as your area under the curve. Okay, so if it's less than, then that means my lower bound is unlimited and my upper is the 65.6. Because 65.6 and less than would be to the left. Okay, then I put my mean. Well, my mean is 64.6. And then I put my standard deviation, which is 2.8. And we round 4 places this time.
Wish they were consistent.
I know. And there's the one on here, do you remember where we were doing the line of best fit and it did the slope and it's on this? So it's like, but we made such a big deal about it. I feel like you'll remember on that one. Okay, now the difference in that one and then the part about the probability of selecting a sample of 18 women is just going to be this last number. You're going to do everything else the same, except on the last number, you're going to take the standard deviation and divide by the square root of your sample, or the square root of n. And our n was 18. So the easiest way would be to go copy what you just typed in, and then at the end, hit divided by the square root of 18, and then close your parentheses.
So it's not over, it's actually divided by.
Same thing. Okay,
Because I know last time I did some problems and I was trying to divide, but, well, maybe it was my calculator that was making me think the opposite.
yeah, since you just have, sometimes when you're dividing by, if there's 2 things in the denominator or 2 things in the numerator, then you've got to have parentheses around it, or you want to think of it as a fraction. But since that's just one number and one number, divided by and fraction means the same thing.
Because I was doing like 2.8 divided by, and then the square root, and it wasn't coming out right.
Okay.
So I
You've
just
just
needed
been-
to do 2.8 and then the square root.
And then I don't know that you'll have this problem, as I think this is a newer thing, but when you type in the square root, it like keeps doing the square root until you hit the right button and get out of the square root before you put your parentheses in there. So,
It's exactly.
uh-huh.
You just,
So all I did was I copied what I had up there already from this previous problem. And then at the end, instead of 2.8, I need to do divided by the square root of 18. That's how I got it. Okay, so which one has the higher probability?
The sample.
Selecting the sample. So you're going to say that it is more likely to select a sample of 18 women with a mean height less than 65 because the sample of 18 has a higher probability. So A and D are similar, but A is saying the probability is lower, but it's actually higher because that's a higher number.
So on the, I'm sorry, I'm still on the second one. What's that, with the, you dividing the standard deviation?
By the square root of n. Okay.
This is. So, wow, 1, 3, right? Positive n. Okay. No, there's 7 of them. So.
See what I mean?
Okay.
So look at that.
Yeah.
Because it's between 100.
Well, you have 2.
Here we go.
Right, so this one might get 8 also.
Bradley's favorite question.
I hate this.
Oh, okay.
I don't understand.
Does that make
What I
sense?
think is right is always wrong.
Sometimes it's like that when we speak it.
Every time, every time.
Josh, get it? He seemed excited about something.
First try, I got it right.
Whoa.
Bonfire my house later.
Okay, moving on to 21. It sounds like y'all are struggling with this a little bit. So number 5 is saying the probability that X is greater than or equal to 119. So when I apply the continuity correction and change this binomial statement to a normal distribution probability with the continuity correction, I just need to think about, okay, here 119 is included. So X values that are greater than or equal to 119 would be like 119, 120, 121, so on. Okay, so this one is going to match up with this because that would include the 119. If I go a half a point lower and I don't include it, if I go a half a point lower and this is just greater than, then it would include the 119. So on 5, it is X is greater than 118.5. Okay. So I went a half a point lower so that I will include my 119 since it's or equal to. Okay. Now on 16, you're including 119, but you want less than. So numbers that are less than or equal to 119 are 119, 118, 117, so on.
Basically, we're remembering taking a half off.
It's going to be either a half lower or a half higher. This one's going to have to be a half higher. That way it'll include the 119 as you're listing things lower than it. So this one is the probability of X is less than 119.5. Okay, then on number 7, if you're lower than 119, you're not including 119 this time. So just numbers that are less than 119 would be like 118, 117, and so on. So that's why this one is going to be less than 118.5. And then greater than 119 is not going to include 119. So that's why it's going to be greater than 119.5.
All right.
All right, y'all slow down.
Yeah, well, I can't see the variables that are in the actual problem, so I can't tell what's going on. I can't even.
Okay, so.
Is that better?
Yes.
Thank you.
So,
So
Okay, so let's look at 8 if you're still confused. If it's saying that it's the probability that X is greater than 119, so that's going to be 120, 121, so on. I'm not including 119. So first of all, they have to have the same symbol. So my choices are here or here. Okay, well, if I say greater than 118.5, that's going to include 119, isn't it? I can't include 119. It's not in my list. So it's got to be this one. So those match. Okay. When I look at number 7, less than 119 does not include 119. Okay. So if it's not going to include 119, you have to pick another probability that's not going to include 119. So it's going to be a less than again. So it's going to be one of these two. Okay, well, less than 119.5 is 119, less than 119.5?
No.
119 is less than 119.5, right?
Oh, yes.
Okay, so it can't be this one. Okay, but it's not less than 118.5, so that's why that goes with that.
Okay, hold on, I'm still confused.
It might help you to think of like a number line. So like here's, for number 8, here's 119. If you want values that are greater than 119, you're not including 119, but you're going this way. Okay. So since you're not including 119, okay, you look at your two choices that matched here and here. Okay, well, if I graph 119.5, let me get another pen color that you could see.
Yeah, I mean.
Not right now.
Yeah.
So if I graph 119.5 greater than 119.5, that would be a right here. Okay. So see, that's not including my 119, but if I graph 118.5, that's going to go right through it, and we're not supposed to be including it because it's not our equal to. So that's why it has to be this one and not that one.
And if it's less than, it's the same thing, it won't
Mhm.
include the number.
Yeah, so it's going to have the same symbol. It's just that none of them are going to have the or equal to.
Yeah, that, the way it's set up too.
Okay, moving on to 22. Find the margin of error for the values given. Your formula for the margin of error is to take your critical number for Z and multiply it by the standard deviation over the square root of N. So when I look up my Z-score, I have to pay attention to the C is 0.95. I click on my chart. Here's what comes up. My 0.95 makes my Z-score 1.96. So I'm going to take 1.96. And then I'm going to multiply it by my standard deviation, 3.6, over my square root of N. So square root of 81
Where did you get your 1.96?
from my chart.
Your chart's on there.
Okay, then for 23, in a random sample of 6 cell phones, the mean full price was $530. So I'm going to label $530 as X bar. So this time I'm labeling it as X bar instead of mu because this is in a sample. Okay. The standard deviation was 158. So I label my standard deviation as S because once again it's in a sample. Assume the population is normally distributed and use the T distribution. So there's your keyword right there telling you what to do to find the margin of error and construct a 95% confidence interval for the population mean. So to find our margin of error, we're going to take our critical number for T and multiply it by S over the square root of N. So this is similar to the formula we used on 22. It's just that this time we're using the T distribution. So we need our T-score instead of the Z-score. So to find my T value, I need to look up my table. Okay, and for some reason my table did not print out, but it looks like it's on your math lab. Okay, so can somebody pull that up for me? And to get my T-score, I need to pay attention to my C being 0.95, and then my N is 6. Okay, if N is 6, that's going to make DF 5. So I need to look up 5 and 0.95.
On a single toe?
On the,
okay, there's 3 things here, so.
so look up the C, not the alpha.
2.571.
Okay, so 2.571 is my number for T. Thank you.
Okay, so it's the T distribution table, that's what we're looking at, so we need to do the DF, because I'm pulling up the one cell, 2 cell.
Right here.
Yes, the very top row says level of confidence C. That's what we're pulling up.
Okay, so that's what we're doing,
That's
the
right.
very top one,
Mhm.
and so we need to do the DF.
Put on 12 cell phones.
Oh, you did the level of confidence, okay.
Yeah, so make sure on that T distribution table, pay attention, it has a C and then it also has the alpha values. Okay, so my S comes from the problem, my N comes from the problem, my T sub C comes from the table that you will have on MathLab. It just did not print out.
So you go to the table, using your.
And so I use those 2 numbers I circled.
Using your confidence interval.
Mhm.
So that's gonna be our TC.
Oh, I know, I'm squinting.
I'm about to break the cheaters out.
Don't make her bring her cheaters out.
I'm struggling.
We'll come up front.
Move up front, there's a whole table with everybody on it.
Okay, and then this little blank after the box which I thought that was weird, that it just has you round one decimal place when it's in dollars, but anyway. Your choices are your units, are they in dollars, square dollars, or cell phones? Okay, and then to do the confidence interval, since we are looking at
Why are there
the,
multiple tails
do what now?
in the T distribution?
Just look at the top row of the confidence level.
Because that's the C. The others are the alphas
Sorry, I'm
for
about
later.
5 minutes behind you guys.
Sorry, sorry, I've already been there, so that's why I'm helping you.
Appreciate it.
You're going to do, when it's saying interval, and since we're dealing with T distribution, you're going to be doing the T interval. So when I go to, oh, this is a test, isn't it? So I go to stat, and see, that's the thing, like I just went to the wrong menu. We've been looking under distribution. I'm not seeing it. Okay, so if I don't see it here, where should I look? What else have we used a lot? Stat,
Test.
test. Okay, and then now I see it. Okay, so don't panic if you're not seeing it somewhere. Go to the other menu we've used a lot. So T interval. This is stats. Remember, data is when you have data points you have to type in your L1. My X bar is 530. My S is 158.
So it's the T test or T?
It's asking me to do an interval.
Oh, so number 8.
So we just got the stats, we don't have it at.
So the SX would be kind of like the standard deviation, so we don't have one.
Mm-hmm.
Is that what you were saying?
Yeah.
So that should be 150. Yes, okay. So.
Okay, so what you entered in, it was the mean, the 530, is that what was entered in? That's the X bar?
What did it ask for?
The X bar.
Mm-hmm. Yep, and then my S is here.
And it's on the other here.
Where do you go to get the interval here?
Stat test, T interval.
Yeah.
You have to go down.
Number, not
You
my
cannot
calculator,
put
number
a
8.
0.5, like if you have like $534.50, you can't put that in.
You should be able
Because that
to.
would be the reason to get an error.
Nope.
Well, that man about,
One.
there's not an ABC, so what's on your page, right? Like you always work as well, like it's.
But he's talking about, like, on this problem on Math Lab, it's already, it
Yeah, it's
gives
all
you,
laid out.
click, it's all already laid out for you. What, yeah, I missed that one. What was the A, B, and C, D answer? Sorry.
It was with 95% confidence, it can be said that the population mean full price is between the intervals endpoints.
All right, you can leave that problem on.
All right, 24.
You're stalling.
Why is it necessary to check in P hat to make sure it's greater than or equal to 5 and in Q hat to make sure it is greater than or equal to 5? It is necessary to check those because if either the values are less than 5, then the distribution may not be normally distributed. Therefore, Z sub C cannot be used to calculate the confidence interval.
It's a mouthful. So pick the longest answer.
Yeah.
I do that stuff too.
Well, they teach you that in high school when you take your SAT and your ACT.
This is the stuff to leave on the
Yeah, we can just do
Yeah,
all
all the-
How many questions are on the phone?
25. Okay, so for this next one, this is the one that didn't have a table on it that I thought should have. So I will, if I can't get it on here, then I will make a copy of the table for you. But,
Oh, this is where you just plug in the number?
okay, so you're going to be looking at the numbers, and this means we're going to use what distribution table?
Chi-squared.
So you're gonna look up the chi-squared. So when you look up the chi-squared, you have a left and a right. Okay, it's asking you for both. You're gonna look up C is equal to 0.98. Actually, that's not what you're gonna look up, because since there's 2, then you're gonna take 1 minus the 0.98 and divide by 2. So that gives you 0.01. And then the other is just gonna be 1 minus 0.01.
You got your point on it from your C.
So because C is 0.98, I put it here. Okay, and I'm going to be looking at 0.01 and 0.99.
So do you subtract 0.98 and then divide by 2, or is that what you're doing?
1 minus 0.98 is 0.02, divided by 2 is 0.01.
Is there any way for like you to do like the same, like make all the reviews the same, like you have that power? No, I didn't know if you did or not.
Mm-mm.
In class, it'd be so much easier.
I don't even know what that question was. What did you?
Like, if all of our reviews could be the same.
So our
like,
answer are
working,
different.
you have the same
Oh,
time,
a
like,
different
that's why I keep
number.
getting confused, because she's saying 98 and I'm looking at 90.
I do that whenever I'm doing when I'm looking at my review and doing my exam or
She can't
whatever.
control that. That's a cheating
The
mechanism.
reason why I'm behind is because I'm answering questions here that are answering different questions.
Well, and that might be like, well, for what, we still have like 7 questions, and we have 30 minutes to finish. So it may be one of those things where you jot down a few things, but then you can go back and look at this
Yeah, I'm
recording
gonna be watching
later.
the video.
Okay.
Yeah, just be careful when you're doing your test, not to look at the numbers on your paper, because I've done that plenty of times.
All right, so for this one, I need to look these 2 up, and then also my DF. If N is 17, my DF is 16.
Why isn't there a chart here for us?
That's what I was saying. I don't know why there's not a table. I'll try to insert that. If I can't, then I'll bring a paper copy.
And what chart are we looking at? The
The chi-squared.
chi-square.
Mhm.
How's that?
Okay, so here, we have a chi-square chart on another problem, but I'm not going to just say, oh, we'll just look it up on another problem, because that would take you a while to figure out which problem to look at.
Yeah,
So
I'll look at all of
we won't be doing that.
What's the
Just remove it.
chi-square look like? Is it just the x squared?
That little funky looking X,
The fancy.
like this.
I think it
Okay.
says it on
The
there.
squiggly
Mine
x?
did.
So I am looking at 0.01, and my DF was 16. So I have 32.000 for one of my numbers. Okay. My other part that I was looking up is 0.99. And so when I look up 16, I have this one. Okay. Now, how do you know which number is the left and which number is the right?
The lowest goes on the left.
Lower number's the left, larger number's the right. Left, right. Okay. So I have,
So the way it asks you on the quiz, you have the higher number first,
yes,
which is totally backwards, maybe whatever.
but that's the first one that you find the number for to look up
The
is why.
first one is the right one anyways, right?
Mhm.
So is it always for chi-squared, is it always 1 minus whatever the confidence
Mhm.
interval is?
And then divide by 2. And then once you get that one, you just do 1 minus that number to get the other one.
All right, so like on mine, I have 80, or, yeah, 0.80, so. mine-
So you do 1 minus 0.8 and then divide by 2. So you're gonna be looking at 0.1. And it means your other one will be 0.9.
Oh, so same thing, it's still gonna be 0.99 and 0.1.
No, 0.1, I had
Oh,
0.01.
0.90.
Oh,
Yeah.
okay.
Your answer goes with the smaller.
Okay, so this one.
Yeah, 0.01.
Mhm.
It's amazing what the difference.
1 penny is different than 10 cents. Right?
So 0.01.
Oh, I
We
love that.
pull up that chart again
This
on there.
one?
Yes.
I know one, you look up on your chart, and that was the biggest one.
Oh, because it's still in the front. I'm thinking,
I
I'm thinking of
know it's not the
this.
same process.
yes, I'm like, that is not bigger.
She definitely can't use our recordings for other classes.
Okay, for 26, we're back to the H sub A and H sub O stuff. So hopefully that's more familiar and we can get through this part a little faster since we're running out of time. But on my
Slow guy.
question, it's asking me first of all to write the claim as a mathematical statement. So my statement is a laptop manufacturer claims that the mean life is more than 5 hours. So my mean is more
Oh,
than
shit, we're
5.
in the sevens.
That's my claim. Okay. And so that's going to be my H sub A. So my first one, write the claim as a mathematical statement. So that is that. And then the only one where I have my H sub A is greater than 5 is here.
I do great on the first two, and then it all goes downhill.
Okay. And then my claim is my H sub A. So that's all this one's asking.
Yes, mine did that when I printed them off too. Mine does the same thing.
Okay, then moving on to 27, it is asking us to use the p-value for a hypothesis test. So what we're using here is the fact that when p is less than or equal to alpha, you're going to reject H sub O. When p is greater than alpha,
You're giving me anxiety right now.
you're going to fail to reject H sub O. So when I'm looking at my p-value, on A, my alpha value is 0.01. Okay. So if I compare these two numbers, p is greater than alpha. So when p is greater than alpha, we fail to reject. Okay. So these are my two options for failing to reject, but am I failing to reject because it's less than or because it's greater than?
Greater.
So I pick the one that says greater.
Okay, this P
Okay,
is
so I
greater.
can see what you have here.
Yeah, I'm just gonna get this part wrong.
After, after doing the review and this thing, I feel like I get this better
Yes,
now.
me too, I understand it so much more.
It's amazing how you use, for 2 weeks, you use like,
Less than.
I really did.
I was.
I was so confused.
I understand, like, I'm really good at the H sub A and the H sub O, I can kill that.
Okay, on this next part, when I compare my two numbers, it's less than. So when it's less than, you reject. And so your two choices for rejecting, I'm rejecting because it's less than. And then my last number, I'm comparing my P with my alpha. Once again, it's less than. So I'm going to reject, and I want to pick the rejection that says less than.
This chart helps a whole lot.
I knew that you all kept struggling with that, and then I was like, oh yeah, we have a chart with that. Maybe that would
I
help.
did this one and I did this one so that you knew which.
The language,
the
so which way to
language.
put.
Chase, if you don't, this one helped a whole lot too. 9 and 34.
So we always, okay, so
This
this is what I did wrong.
Okay, 28. First of all, it's saying a t-test, so keep that in mind. Okay. And then our claim has to be our H sub A. So I'm looking for H sub A not equal to 25 to tell me my null and alternative hypothesis. Okay. Now, the next part, it's asking me for the standardized test statistic. We do have a formula for that, but you're going to have to do the t-test anyway to be able to get the p-value. So you can just use that t-test to get both of these if you would like. Okay, so it's a test, so I'm probably going to find it where? Stat test. And sure enough, number 2 is my t-test. Okay. Now we have stats. We do not have data, so I'm on stats, and then I type in my 25 because that's what I have my mean equal to and my hypothesis. My X bar is, I type that in from the sample statistics over here. My S, I type that in. And I type in my N. And then the next bar, I type in my H sub A, or I select my H sub A. So this time my H sub A is the one that's not equal to. And then I calculate. Okay, there's my T for my standardized test statistic. And then my P value is right after that.
Can you go back on the calculator screen? So we're using the first function because of the, instead of like on the main part, like when we have, that's the blue. Where you have to choose.
Yeah, that has to match up with the H sub A. Mhm. Okay, when I can decide whether to reject or fail to reject, I'm using my p-value, just like I did in that last problem. I'm comparing it to alpha. Okay. Well, p is greater than alpha. So when p is greater than alpha, then we're going to fail to reject. So these are my choices here. Okay. And so to figure out the wording, this is what I sent you all the text on Friday. Use this chart. Okay. So my claim here is my H sub A. So since my claim is my H sub A, I'm going to be here. We are failing to reject, so I say there is not enough evidence to support the claim. So when I'm choosing either A or B, which one says there is not enough evidence to support the claim? So it's that one. So when you are getting mixed up on the wording, use this chart.
Yeah, because you look at the.
Yes.
first, and then you look at the.
So when we do the t-test, is that supposed to be plus, or like positive and negative because it's, or am I thinking
That
about
would-
a completely different thing?
No, you're looking at critical values, that's where you do plus and
Okay,
minus.
so
Yeah, we're
it's
not
supposed
there
to
yet.
just be on this,
Yeah.
1 point, well, I know it's not the same as yours, but 1 point.
So t-test is not the number. So t-test, you
But
don't.
then the
So when
p-value
you fail
comes
to
from the
reject,
t-test,
is
Don't
there
write
always
that
there's
down.
not enough evidence?
Like soon as I hit calculate, my T and my P are right there.
This is bigger, so this is bigger.
Because Penn says, and then this is bigger.
Yep. And if you have to stop and think about that. and it's-
Okay, that's not me.
Mhm.
Okay.
Okay, on 29, here's my claim. It says, educational researcher claims. That's the very first question, identify the claim. My claim is that 58% of college students work year-round. That is going to be my H sub O, that my P is equal to 0.58.
I don't like that you have to keep changing the book.
Okay.
Real quick before you get into it,
Mm-hmm.
I know the last one, you failed to reject,
Mm-hmm.
but why are you failing to reject?
Because up here, you're pairing P and alpha. When P is less than alpha, you reject. When it's greater than alpha, you fail to reject.
I write it out like this and it helps. So I do, the P value is 0.172, and alpha is 0.055, right? So this one's greater,
Because this is greater than that.
this one's greater, so P value is greater. So based off that chart, we were given H sub O, right?
Yeah. Same as H of O. H of A.
Here, you don't have
Yeah,
printer.
H sub A. We were given H sub A, right? And then P is greater than alpha. So we still.
Do you remember, is it
I'm gonna need to
7.1 or
copy
7.2?
this.
Yeah, it's on
Here.
our PowerPoint.
Yeah, my problem,
Yeah,
I
I
have to
don't
figure
have
out whether
this.
you use P,
Oh.
mean,
What was
You
that
don't
one?
need this?
I have a printer.
Oh, thank
Is
you.
it 7.1 or 7.2?
I think it's 7.1.
Okay, yeah, I'll work with that. If you need something else, print it off.
Sorry.
She's already done it.
Okay, so my claim was the 58%. I've identified H sub O and H sub A. Now I need to find my critical values for my test, and it's telling me that it's a Z score for my critical value. So it gives us the standard normal distribution table, but this is the one we did not use the table for. We put it in our calculator. So you do the inverse norm. Your first number is your alpha value. No, yeah, your first number is your alpha value, but this is two-tailed because of this. So I have to take that alpha value and split it. So that is because I have 0.10 over 2. And so when I type that into my calculator, that'll give me my Z-scores. And since it's two-tailed, it's going to have plus or minus the 1.64. So when I type this in, it gives me the negative, but I've got to remember this was two-tailed, so I have two numbers here, so it's plus or minus. So that means my rejection region is going to be less than the negative 1.64 and greater than the positive 1.64.
Is your alpha 10.61?
My,
Okay.
So alpha over 2.
And I think in math, like you have to do the negative in front of that. Because for some reason I was thinking that the less than would replace that negative sign, but it doesn't. So you have
And
to
that's
do-
because like these are your two tails here. This one's your negative and this one's your positive.
Right.
Okay, so that's why it's less than on this one and greater than on the positive. And then to find our standardized test statistics, we're going to take P hat minus P, and we divide by the square root of PQ over N. Now, my P value, I know that's 0.58. My P hat, they don't really tell me the percent for our sample, but they give us numbers for our sample. So I can still find that decimal value because my problem says that in a random sample of 300 college students, 174 say they work year round. So to find that percent, I'm just going to take my 174 and divide it by my sample size. So when I put that in my calculator, I end up with 0.58. So that makes my p hat 0.58. Okay. So now when I use this formula, p hat minus p, my p hat is 0.58. But my p also ended up being 0.58 because that's what was in this.
Oh, this is one of them. Makes that zero.
Mm-hmm. And so you really don't have to worry about all this stuff at the bottom because if it's zero on the top, it's just zero.
How do you know what p hat? P hat or p?
P is here. P equals 0.58.
Okay.
Okay, and then I just found my p hat because it didn't tell me the percent in my sample, but it told me how many students were in the sample and how many said they worked year round. So I divided that to get it.
So 174.
Okay. Now, here's my picture of what's going on. There's my zero. Is it in the rejection region?
It's in failed to reject.
Mm-hmm. Okay. So you're going to say, okay, do you reject or fail to reject?
Failed to reject the null hypothesis.
Okay. And then now what I need to do is look at my chart. Okay. Was my claim the H sub O or the H sub A?
H sub O.
H sub O was my claim. Okay. So that means when I look at my little chart here, my claim is H sub O. I'm going to do one of these. Well, did I reject or did I fail to reject? I failed. So there is not enough evidence to reject the claim. So there is not to reject. So I think that you all were getting, for the most part, whether to reject or fail to reject, but what you were getting confused on was the wording on these last two. So use the chart to help you with that.
Where did you get the 174? 300 is the sample size. But
And then how many out of that 300? I had 174 say that they worked year round.
oh, nice.
Okay, find the critical values and rejection regions for a right-tailed chi-square test with the sample size n equals 14 and a level of significance of alpha equals 0.10. So I know I'm going to need to look up that number in my chart. And then if n is 14, what's DF?
13.
So I'm going to need to look up this in my chart. Okay, it's also right-tailed. Okay, so that's a good thing. I can easily tell my graph, this is the only one that's right-tailed. And then to find my critical value, I need to look up DF is 13 and alpha equals 0.10. So here's my chart. There's my 0.10. I'll do this in purple since I've already written on
This
it.
one you go down to?
No.
No,
This is a single
because you
code.
only have one set of data. We went down 2 when we had an X and a Y. Okay. But this one, I look up DF of 13 here. And so there's my number. Only 2 more. I think we're going to make it, y'all, because this one doesn't, it's just a vocab. What does R represent?
R. P is row, I know that.
Mm-hmm. Okay, and then rho is the population. P population, right? Okay, then our last question. I need to go to stat and type in my data. So I'm gonna clear out my stuff from earlier. And I am typing in my hours spent studying in L1 and my test scores in L2.
The first one is sample and the second one is population. R is sample. Correlation coefficient and P is population correlation.
Okay, the regression equation, in order to get that, you're gonna go to stat and over to calc, and it's line reg, number 4. Stat, calc, and then number 4.
Another 6.
Now, mine looks like it's a little messed up here. It says my X's are in L2 and so are my Y's, okay? My X's are actually in L1, so I need to hit second 1 to get L1 to come up. Okay, skip the frequency list and then store reg EQ. This is the part, I am gonna need to store my calculator because my next question is asking me to choose the correct graph with the line drawn. So to get this part, I go to vars, y vars, function, y1.
Chase, we have to do this one different.
If you wanted to store it.
So we have to do it each, on each
Yes,
problem.
like when you do stat count, line reg, then you immediately go to bars, y bars, and 1.
Okay, this is also the tricky question where it asks you to do the slope to 3 places and the y-intercept to 2. Okay. So I have I've typed something wrong because this isn't right.
No, I didn't put that.
1, 1,
Oh, which one?
2, 4, 5, 5, 39, 43, 52.
So you don't have a score, right?
And you all figured out how to do your part, the 83 people?
Have a score.
You have to put it in parentheses. So yours will look like,
I think I got it. I just have to enter it in differently. Because when I enter it in, I have what you have up there.
I think if you do it like that, sorry, you can't see that. It should work. Okay.
It was last time, so I think that's good.
I do the math.
I do the math every time.
I hate that chart. I hate that.
1, 1, 2, 4, 5, 5, 39, 43, 52, 49, 63. Goodness, I messed up 2 of them.
So whatever this is, whatever you get for y with the next one, then you just plug in 4 for x.
Oh, you don't use your calculator?
I do, but I don't use the chart function. I was like getting myself super confused in the chart.
Okay, y'all know how to do the last part?
Yeah. The one thing I'm real confident about.
Yeah.
I'm just kidding. As long as you get that equation right.
And you know when it's not meaningful.
Yes, when it's outside the.
Good, good. Okay. Think we're in good shape
We
then.
did it, y'all.
I think we did.
Y'all.
Hey, I have a question on one because I would like it.